Hi everyone, in this video we're going to start working on solving oblique triangles, triangles that do not contain a right angle. So to get us started, we want to look at this triangle and we want to think about this as our motivating question. If I know angle alpha and beta and I know side A, could I find side B? That's the question we're going to use to kind of get us started on this. So I've done a bunch of labeling and messing with things. So I've labeled in green the angles and the sides that we know, and in red is the side we're looking for. I also have angle gamma and side C that I don't know, and I'm not really interested in getting mixed into this question because I'm not interested in knowing them. So the answer is, if we're working with an oblique triangle, what we would generally do is we would drop a perpendicular and split it up into two different right triangles. So I've labeled side H because we sort of get forced to look at that triangle or that side length as something that's part of both of our right triangles. Okay. And since we're working on law of sines, it seems like a good idea to see what sine of alpha will tell us. So if I'm starting at angle alpha, sine is going to equal opposite h over hypotenuse b. I don't have red, but we'll use a b. Oh, and this beta is supposed to be green. We know beta. Okay, so green is what we know. Red is what, pink is what we don't know. All right, and we can also look at sine beta. So we have both of these angles. And from beta, sine is going to be h over a. Okay, so now we've got our unknown, we've got a known, and then we've got this extra unknown that we don't really like. So let's go ahead and rearrange just a little bit. If we solve this for h, we're going to multiply the first one by b, and get b times the sine of alpha. And then for the second one, we're going to get a times the sine of beta. Okay, so we get these two statements. Sorry, that looks a little bit hard to read. Let me zoom in for you. There you go. So we get these two statements. And each one of them is an h equals. So basically, if h is equal to b times sine alpha and it's also equal to a times sine beta, then these two things have to be equal to each other. So we can conclude that b times sine of alpha is equal to a times sine of beta. And notice that what this has gotten down to, if you can see my colors very well, is a single equation involving the three things that we know, alpha, beta, and a, and the one thing that we don't know, which is b. So this could easily be solved for b just by dividing by sine alpha. So done with the original problem that we talked about. But what I actually want to look at is just setting this up in kind of a nice way that puts together pairs. So alpha and a are a nice opposite pair, and beta and b are a nice opposite pair. So again, this doesn't answer the original question. To answer the original question, we just divide by the sine alpha. But just as kind of a sidetrack to get us to law of sines, I could divide both sides by a and b, and it would give me that sine alpha over a is equal to sine beta over b. And this is the beginnings of law of sines. So it doesn't have to be rearranged in that order, but it just makes it really easy to remember that it's sine of alpha over the side opposite, and then sine of beta over the side opposite. And you could continue to fiddle around a little, and what you'd find is that this also would work if either one of those was side C and angle gamma. So we actually get a three-part, pick your favorite two. This is law of sines. So again, you don't have to use all three at once. The idea would be you can say that sine alpha over A is equal to sine beta over B or sine gamma over C. And you could also say that sine beta over B is equal to sine gamma over C. So pick any two and they should be equal. So law of sines works beautifully if you pick your two ratios and you know three of the four things that we've got there. So if I know A, B, beta, I can find alpha. If I know alpha A, B, I can find beta, and so on. So what this ends up being, there's sort of a short way to describe what law of sines works on. It works if we know angle, angle, side. That's what this first one is, angle, angle, side, or angle, side, angle, or angle, side, side. So let me just make sure you're clear on what that means. I have some oblique triangle sitting out here. I'm not assuming there's a right angle, even though mine kind of looks like it might have a right angle. So angle, side, side would mean, for example, I know this angle, so this is angle 1, angle 2, and this side. That would be angle, angle, side. It would also work if I knew A2 and say this is A3 and I knew the bottom of the triangle. So anytime you can say in that order, and you can go the opposite way as well. You could go angle, angle, side, and that still works. So two angles and the side that's not in between them. That's what angle, angle, side is. So law of sines will work on this because we have a known pair, angle 1 and our side, and we could use this to solve for the bottom of the triangle because we could pair that with our other known angle. So that's 3 out of 4 things. Angle, side, angle, that's saying that we know the two angles, any two, and the side that's between them, that's an angle, side, angle. And then angle, side, side is saying we know only one angle, and then we know two of the sides. And really, it could be any two sides. It doesn't matter. So when we only know one angle, and we know, well, that's not true. It couldn't be any two. If we had this S1 and the bottom, that would be a side angle side. So it's specifically two sides in the angle that's not between them. So whether you have the odd man out in the middle or not does matter. So this is the side between the two angles. This is the side not between the two angles. This is the angle not between the two sides. And normally you will see this one in side, side, angle order because it's rude to write it as angle, side, side, even though it means the same thing. But I'm deliberately going to write it in this order because angle, side, side is absolutely a pain in the ass. It can be trouble. So I want you to remember that, and that's the way that I would remember it. Okay, so this is our law of sines, and I want to talk a little bit about why angle, side, side is a pain in the next video, and then we'll get into some examples. Thanks for watching.